Hello everyone, I am Indumati. I will be explaining pure decomposition in mathematics. It is one of the most important matrix factorization techniques used in linear algebra to simplify complex problems. We will begin with the introduction to pure decomposition and its significance. Then we will explore the mathematical definition and basic formula. Pure decomposition definition of mathematical definition of pure decomposition. Pure decomposition expresses any given matrix A as a product of two matrices Q and R. Here is a pure orthogonal matrix, which means its columns are perpendicular unit vectors and R is a upper triangular matrix. This method is extremely helpful in solving linear equations and improving numerical stability of computations. Pure decomposition is widely used in different areas of computation. It solves linear least square problems efficiently, which are common in regression analysis. It also simplifies the process of finding eigenvalues and eigenvectors of matrices, and finally it assists in calculating matrix inverses and making complex mathematical problems much easier to handle. It is a foundation for many algorithms in maths, engineering and data science. We'll see the Python problem. This code implements the Graham-Schmidt process to factor a matrix A into A is equal to QR, where Q is the orthonormal column, R is upper triangular. The columns of Q, the same column of A, has the same column of A. First line we have imported numpy as NP, imports, which means the imports numpy of library of matrix and vector operations. Then we have defined the function that takes numpy array. Then in the indentation it gets the matrix dimensions, which has m and n as the rows and columns. Then we have created two arrays with uninitialized contents. Q is indented to hold orthonormal columns. U is used as temporary storage for orthogonalized vectors. Using np.empty, and we have used the memory uninitialized. Then U equal to A array, which means copying the first column of A into the first column of U. Then Q array equal to U array divided by np.lineal.norm, means normalize the first column to make unit vector and store it in Q array. This is the first orthonormal basic vector. Then we have given a loop which is from the range 1 to n, uses n to set the number of rows, only works if the matrix is square and rows and columns are equal. Inside the loop we have given start the original column, then we have iterated the previous orthonormal vectors with for j in range of I. Then we have used Graham-Schmidt projection step. Then Q equal to U vector divided by np.lineal.norm, means normalizing the orthogonalized vector to produce orthonormal Qi. If the vector is 0, the division will fail. Then R equal to np.zeros, which is creating R, but its shape is wrong. R should be number of columns comma number of columns, that is square with dimension equal to number of columns, not n comma m. For I in range of n and for I in range of I comma m, this iterations given that the upper triangular part of R with inner products of Q and Q array and A array. The formula is correct in principle, but the loop bounds and the R's depend on the correct rows and column naming. Also, many implementation compute R during the orthogonalization loop. Then at last we have printed the Q matrix and R matrix using print statements.